Next, we'll be quickly moving to a circular patch antenna resonating at the same 5 GHz as seen in the previous video. If you've not, here's the link in the description below. So from a 5 GHz patch antenna that we built, now we simply have to change the patch geometry to a circle. So what you're going to do is we're going to quickly delete the patch, rectangular patch, and add a circle of radius r. Now the tweaks will be showed in the video. Now it is important to figure out the dimensions, so the formula to find out r is also given in the description below for the particular frequency. So in the same project, if you want, you can follow the steps that I am doing. I went to inner conductor because I had fused inner conductor with the patch, and I went and found the patch and then deleted the patch along with the inner conductor. So once you're done with that, what you have to do is quickly go to modeling, select a cylinder. This will be our patch underscore circle. The outer radius r in a radius 0. We are placing it at the center of the substrate. X center and Y center 0, 0. Z minimum and maximum will be from h by 2 to h by 2 plus t, and material as it is remains as copper. Now we are simulating with r is equal to 8 millimeters that we got from the formulas and derivations given below. So now with respect to a circular patch antenna, all we can change is the microstrip or rather the patch coaxial feed where it is being given, because from 0 to r the impedance varies as 0 to 200 ohm from 0 to r, and the radius defines the resonant frequency. So accordingly we have to tweak those two parameters. Now once we are done with our circular patch, we go on inserting an inner conductor, outer conductor, and dielectric, all before that we create a hole. Now remember that tweaking the position of the coaxial feed line, we have to start from, let's say from the center, we can start from r by 4 to other values like r by 6, r by 3, r by 3.5 accordingly, because from 0 to r the impedance varies from 0 to 200 ohms, and we have to make our antennas 50 ohm impedance. So accordingly, here are some trials and errors that I have simulated. So this is the inner conductor, outer radius remains as 0.5. The X center here, we're defining it as r by 4. Z minimum stays from minus h by 2 minus t minus 2 to minus h by 2 minus t. Okay, this is the inner conductor, so plus h by 2 plus t. Material is copper. Simply you click on preview and we have our inner conductor. Now quickly go on outer conductor. Here we simply change the X center from x by 8 to r by 4. Everything else remains the same. Similar thing for the dielectric and the hole that we created previously in the patch rectangle. This is the outer conductor that we changed, the dielectric that we changed. The outer conductor we changed prior to that, the inner conductor we changed first, and now we simply go on to infuse the inner conductor with the patch circle. Simply click on inner conductor, shift plus with the patch circle, enter. Also we had fused earlier the outer conductor with ground, so these are the ground parameters. remember that. In ground itself we had a hole that we had made, so we go back and we find the ground hole. So we found the hole and we tweak the x center from x by 8 to r by 4. Click on preview, and okay, and we can see that we are done with our circular patch antenna. Make sure that our feed line and the port remain proper. We'll quickly simulate it and view the results. Now you go to the 1D parameters, S parameters, move axis marker to minimum. So we have a resonant frequency at 4.884 gigahertz and a return loss of minus 15 decibels. Now we need to improve our resonant frequency as well as our return losses. So for that we will reduce the R value in order to get a closer frequency, since the resistance is inversely proportional to the frequency. And we'll also tweak how we view the distance of our microstrip of our coaxial feed line. That is, we'll tweak it from r by 4, we'll go to r by 6 and then r by 3 to see which direction do we get 50 ohms. So we'll first proceed with changing the value of r. We simply change the value of r and we decrease it in order to get a resonance of 5 gigahertz. Go to schematic parameter list, click on R and we reduce it to 7.702 millimeters. Save and 3D, press F7 and we simulate it just to get a resonant frequency of 5 gigahertz first. S parameters. Now we can see the green line or this graph move axis. So it's 5.064. So we can slightly increase the R length in order to get our resonance at 5 gigahertz. That we'll do, but we'll now primarily focus on getting a good return loss, preferably greater than 20 dB. So tweaking R to about 7.74 millimeters. Save that. Go to 3D, press F7. Now wherever we change the R values to R by 4, we simply go there and press R by 6. Now instead of doing that, you could give a variable. Let's say you can give a variable as T, or we've used T already, so we can give a variable as M, and then we can tweak the value of M as R by 2, R by 3, R by 4, R by 6, whatever we want. So that makes our job easier. So this is a simulation at R by 6 and 7.74 millimeters as the radius. We can view the results, and then accordingly we can see whether we have to shift our coaxial feed cable more towards the center or away from the center, or more to the left of r by 4 or to the right of r by 4. We wait for it to simulate, and then based on the return loss values we tweak them. Remember that wherever we had r by 4, you have to change that. So this is what we are getting. 4.992 is excellent for a 5 GHz patch antenna. However, the return loss is deteriorated. That means we have to go and have it to the left of r by 4, that is between 0 and r by 4. So let's try with two types of values, r by 3 and r by 3.5, and accordingly we might get better results. So change it to r by 3 everywhere. Now a quick mistake in the video that I've done is I did not change the parameter of one of the feed line parts to r by 3, which is the cylinder of hole, I think. So that you have to avoid, and make sure that you change each and every parameter where r by 6 existed, and you can simply see from the simulation. Remember to press Ctrl save after each and every edit in order to maintain your work. So we've quickly simulated it. We go to 1D results, S11 parameters, and as you can see that our frequency shifted slightly. However, we got a good return loss of minus 20.66299 dB. Now we focus on getting a slightly better return loss and our exact resonant frequency of 5.096. So what I'll be doing is I'll be quickly changing the R value to 7.74, because I need to reduce the frequency, so I slightly tweak the length and increase it. And everywhere where I had R by 3, I changed it to R by 3.5. So yeah, once you are done with tweaking all the parameters, simply click on Ctrl S and simulate our project, and finally we can view the results as 11 parameters as well as the far field plot for 5 GHz circular patch antenna. We can see that we have a good 5.06 GHz resonance and minus 25.72 return loss dB, which is exactly what we are wanting to achieve via the simulation. Quickly go to show measure lines, 10 dB, and we stretch that frequency lines to intersect with the 10 dB and our curve, and we simply find the bandwidth using the formula. Bandwidth is equal to 2 into d divided by f1 plus f2, so 2 into 0.20495 divided by 4.9587 plus 5.1636, and we have to get the bandwidth in percentage, so it has to be lesser than 5% is the ideal goal. Let's see what value we get. Okay, so we are getting a bandwidth of 4.05%, which is excellent. And we go back to the far field plot. For the far field plot, again, we have the same 6.3 dBi gain.